Yeah, you can start the video. So if you have to leave in the middle or whatever, we're posting this video, and we should be posting the slides to Learning Suite or sending them out on email. So just look out for those. Okay, and we're gonna go ahead and get started. So just quick, things that you want to use to prepare. The lecture slides and your notes are great. The SmartWorks and recitation problems are great. And if you want extra, just go to the back of the book, and those are great resources as well. You can always just Google what type of problem you want, and those are fine too. Also, things from 105 you want to know. Solubility rules, you want to know naming, and you especially want to know intermolecular forces. Okay. And sorry if my voice sounds bad, I'm just getting over being sick, but that's it. Okay, so quick, we just want to review what solutes, solvents, and solutions are. A solute is typically a thing you're going to add to a solvent, so like salt. The solvent is what's going to dissolve it, or dissociate it, and then the solution is the total thing. So like salt water is a solution, water is a solvent, and salt is a solute. Pretty basic. Questions on that? And like I said, it's always, or pretty much always going to be water for this class, but just know there are other solvents. Preparing solutions, so just really quick, the steps. You want to clean your glassware beforehand, rinse it out 3 times, and you want to add a little bit of water, and you do that so that when you add your solute, it doesn't stick into the glass, like get ingrained in the glass. And then you want to fill, or add your solute, and then you want to fill to the line of however much volume you want. And then you want to mix by inversion 3 times, just so it's all equally concentrated throughout. If you read this one.
Sorry about that, everyone. So this is a great problem right here. That what we're talking about here is conductivity. And so, does anyone know how to do this problem? Does everyone know how to do this problem? So what you look at right here is you look at, okay, I have a concentration of electrolytes, because electrolytes are what conduct in a solution. So if you plug in 2 wires, and you'll be able to light up a light bulb if you have it in a correct solution. That actually has electrolytes that can conduct the charge from the wires. And so the trick with these problems is that you have to be really careful that you don't just select the highest concentration. Because probably what your gut says is I'm going to go with 1.5 molar sodium chloride. Or if you really just went by concentration, you go with the glucose. But the thing about glucose is it's not an ion. So that's something you have to remember, is that it is not an ion, does not dissociate in water, and so it does not have any electrolytes with it. Whereas sodium chloride, calcium chloride, and phosphoric acid, they do. And so what you have to do is you have to multiply those numbers by the number of ions that are associated with them. So the correct answer is calcium chloride. Because you have 1.3 times 3 ions that it dissociates into. Does everyone understand that? That it dissociates into the calcium 2+ ion, and then the 2 chlorine minus ions. Yeah?
Is that last compound, H3PO4, is that soluble in water as well?
No, it only dissociates a little bit.
Yeah, so it's not so that's the important thing about this question as well, is that the phosphoric acid doesn't totally dissociate in water.
It's going to dissociate like 1/1,000,000 or something. So.
Yeah.
So if you have like 2.7 molarity CaCl2, would that be more conductive than 3?
Correct. Yeah.
I didn't know that phosphoric acid.
The solubility rules. Yeah. So that's one thing that if you don't know your solubility rules, I'd go back into your 105 material and look over that quickly. Yeah.
So you'll multiply polarity by the number of ions that could be represented?
Yes.
Okay.
Okay. So moving on.
Quick question.
Yes. Okay.
Does the amount of the charge affect your cell? So for instance, if you have like a +2 and a -2, would that be more conductive than the same amount as a +1 and -1?
Yes, it would. It would.
Could you repeat that?
So when you have for example, if I had, let's say I had calcium chloride versus, let's see, can I think of a good example?
I don't think that applies.
That's not really
because
applicable.
Anytime you have 2 plus ion, you're gonna have 2 minus 1 ion, so you're still gonna have 3 ions. So
Yeah.
it doesn't really matter.
Yeah, so
That's not gonna be tested.
it just depends on how many ions you have that makes it more or less soluble. I mean, not soluble, conductive. That's what I meant to say. Yeah.
So with stuff that's soluble, neutrals and stuff in 1 of 5 is that posted anywhere? Like, where would you recommend refreshing on that stuff?
Your 1 of 5 notes, really the only things that you really need to know. Your textbook is great as well. We're not going to go over here in this review today because we need to focus on the material that you guys have learned so far, and we don't have that kind of time. But your textbook would be awesome for learning some of these things. But really the main thing I would focus on from 1 of 5, if nothing else, is intermolecular forces, remembering those. That's really important. Okay? All right. Yeah, so let's do this problem real quick up here. It's a little bit tricky because it's asking you not for the concentration of the sodium phosphate, but it's asking you what the concentration of Na plus is in that. So I'll let you guys work for like 1 or 2 minutes on this on your own. You can chat amongst yourselves, and then we'll come back and we'll solve it together, okay? Okay, so the answer is, first what you do is you go 0.46 grams of sodium phosphate, and then you go convert that to moles, and then what you do after that is you have 100 milliliters, so 0.1 liter, right? And then you have 3 moles of Na plus ions for every 1 mole of sodium phosphate. So in every single mole of these, I have 3 moles of this. And so I'm able to say that I have to multiply whatever concentration I have of that in molarity to the new concentration of sodium ion. Does that make sense to everyone? All right, pretty simple.
Do you have the answer?
Yeah, the answer is, thank you, 0.084 molar sodium ions. Everyone get that? Yeah, and so this problem right here, unless anyone has any questions about that last one. So this one's exactly like a problem that you guys saw on your recitation quiz, and I saw that a lot of you have questions about this one. But the key to understanding this problem right here is understanding that this is not the initial concentration. This is just the initial flask that you have. But then you remove 10 milliliters from that, so that is your initial volume. So your initial volume of this initial concentration. So you're basically just doing M1 V1 equals M2 V2 twice. You're doing that 2 times. And so you're doing 2 dilutions. And so you have to remember just to do it the same way each time. And so it's not a super challenging problem if you think about it and you get past kind of the wording. And so, does anyone have any questions about, we're not going to focus a ton on doing M1 V1 equals M2 V2 problems, unless someone has a specific question about that. No? Okay. Yes? Okay.
Yes. For this one, for example, we're starting off with 10 milliliters of 0.8 molar hydrochloric acid.
Yeah.
We put into a 200 milliliter flask the volume, and the second side of the equation, 200 milliliters or 190 milliliters?
It would be 200, because that would be your because what I said is if you read the problem, you say like you fill it up to the mark. So your new volume is going to be 200. So it's not the amount that you add, it's just the total. Does anyone else have any questions about that?
Do you have the answer on that?
Yeah, the answer on that question would be 8 times 10 to the negative 4. I'll write that up here, and if you guys want to do it on your own at some point, you can.
Okay. Questions on that one? Yeah. Okay, so you do M1 V1 equals M2 V2. Okay, so your M1 is going to just be this molarity that you usually have. So that's going to be your 0.8. Okay, your V1 is going to be the amount that you removed into a different flask. So that would be your 10 mils. Okay, your M2, you're going to have to solve for that. So that's your variable. Your V2 would be your 200 mils. And that's because, like he asked, when you're calculating molarities, you look at the volume of solution, not the solvent. So that would be your 200 mils. Okay, so you do this times this, divided by this. So that's going to be 0.2. 0.4. Okay, and that is your new M1 V1. So you're going to do another M1 V1 equals M2 V2. So you use that molarity, so 0.04. And we move it into, no, sorry, yeah. So 0.04, and you remove 10 mils of that. So your V1 again is 10 mils. Your M2, you want to solve for that again. And your V2, 500. Okay, so you can do 0.04 times 10 divided by 500, and that will give you, hopefully, that. Did you guys get this? Okay, sick. Okay, moving on to enthalpies. Okay, so you're going to want to know all the different kinds. There's delta H of reaction, and that is, simply put, when you look at some reaction, it's the enthalpy involved with that. I don't know how to explain it other than that. Are there questions on that? Okay. Delta H of fusion, we'll talk about that one in a second. Same with vaporization. Formation is the amount of heat produced or released from a formation of 1 mole of a substance from its standard components. So that would look like something like